You can write perfect-looking code and still ship a bug because control flow and state interact in time. The CPU doesn't understand intent. It executes paths in order, using whatever state exists at the moment. Control flow is not formatting. It's behavior you can predict. Execution has a hidden variable, time. Every statement runs at a moment, and the moment determines which value is visible. Think of state as snapshots. The CPU reads the current snapshot, then writes the next snapshot. There's no later explanation stored anywhere. If you don't model time, you'll mispredict behavior. So when you debug, don't ask, what should this be? Ask, what is this right now at this line after the line that already ran? Stepping in a debugger forces this discipline, and that's why it helps. It's also why should is not a debugging word. Only is counts. Same lines, different outcome. In the first version, we set the flag, then we check it. In the second version, we check first, then set. Both compile. Both look reasonable in isolation. But the CPU reads still state in the second case, because the write happens too late. Trace the read first, then look upward for the write that should have happened before it. If the write is later or conditional, you found the problem. When an if runs, execution chooses one path. After the block ends, the path does not exist anymore. Only state persists. The program does not remember which side ran. It only remembers the values that were written. So you can't debug by vibe like, I'm in the admin branch. You debug by values, what got written, and when it became visible to the next line. A branch is a temporary fork, not a permanent identity. The branch history illusion is where bugs live. You'll see code that assumes the path is still true. If access is 10, admin branch must have ran. But access could be overwritten, defaulted, or set by a different path earlier. The CPU doesn't carry your story forward. It carries only values. If you need history, model history, store it, pass it, or compute it again. Otherwise, treat every later read as independent. It sees only the most recent writes on the executed path. Logs should record values, not feelings. Defaults are still state. Unassigned doesn't mean uninvolved. In many languages, a variable has a default value. False, 0, null, before you ever touch it, and control flow reads it like any other value. So this code works, but behaves like not approved every time. That's not a crash. It's silent behavior. Highlight the first read of every variable. If the first read happens before the first write, you found the default-driven branch. Don't let defaults be your decision maker. Initialize on purpose. Early returns don't just exit, they delete futures. When the CPU hits return, everything below becomes unreachable for that run. That means your system isn't just what lines exist, it's which paths can reach which lines. Good design adds returns to prevent dangerous paths, but accidental returns can silently skip required work. When you add a guard clause, you are literally removing a path from the system. If something sometimes doesn't run, your bug might be a return, break, or guard you forgot was possible. Design is path control. Your system is the set of execution paths that can happen, and the state each path leaves behind. If you want fewer bugs, reduce surprising paths, reduce hidden state, and make reads happen after writes on purpose. Trace one function today and label every branch, every write, and every read. Then refactor with confidence.